Right, this problem says a projectile is launched at an angle of 53 degrees with an initial velocity of 34 meters per second from ground level. What is the horizontal range of the projectile? So we're going to use our range equation, which remember only works for projectiles launched from ground level. So that's delta x, which is our range, equals our initial velocity squared times sine of 2 times the angle it's launched at, all over g, which is our acceleration due to gravity. So what we know here is we know our initial velocity is equal to 34 meters per second. We know the launch angle is equal to 53 degrees. And we also know our gravity is either going to be 9.8 meters per second squared, or is going to be 32 feet per second squared. And we're going to want to use the 9.8 meters per second squared because our velocity is also in meters per second, so we want to make sure our units match up. So if velocity was in feet per second, we would use 32 feet per second. And then what we're looking for in this problem is delta x. So delta x is our unknown, and that's what we'll be solving for in this problem. So now we'll substitute in what we know. We get 34 meters per second, that quantity squared, times sine of 2 times our angle, which is 53 degrees. And then we divide that by the acceleration due to gravity, which is 9.8 meters per second squared in this problem. So when we solve that for delta x, when we do that math, we should get delta x equals 113 meters for our distance. So that's our answer. So what this means is that a projectile launched at 34 meters per second at an angle of 53 degrees would give us a horizontal distance, would travel a horizontal distance of 113 meters before it hits the ground. So to draw out what would happen, we launch a projectile here, it's going to travel in a parabolic path, land there, and this distance with the initial conditions we have would be 113 meters.